Alrighty, welcome back. So where we left off, we imported all of our assets that we were going to be using, all our free assets. Anyways, we started off by slicing our character sprites up so far. So we sliced the sprite up, got them all the individual different sprites going. We created a prefab with the graphics, and we started working on creating our animator here with our blend tree with our idols going. And I spelled idols wrong. Huh. So we have our idol blend tree in here. And so now what we are going to need to be doing is to create a script to control our character here. So there are many ways, different ways to create our character scripts. Um, you can select your character here, click add component, and hit new script here. That's one way. Another way to do it, since we are creating our scripts in our scripts folder, is to select our scripts folder and create new C# script. And it creates the new C# script. The other way to do it is to open up the script in your script editor. It takes a minute sometimes. Okay, so now that I'm back, make sure I'm recording still. Yep, I'm still recording. Alright, so now that I am in my script editor, I am actually using what they call Rider. So if you come in here to Unity, is it under Edit, Preferences, I think. Yes, Preferences. You have your External Tools option. You have your External Script Editor. You can open by JetBeans Rider. These are the different options that I have. Currently, I have installed Rider, the newest version of Rider, so that is the one that I'm using. I just prefer that. You could use Visual Studio; it works just the same. However, whatever, and I think you can use by file extension. I think Unity internally will use your model behavior. That's comes default, or it used to come default anyways. Visual Studio might come default now. I don't remember. It's been a while since I've installed it. I switched over to Rider just because I like the features in Rider. It's less cumbersome and doesn't take as long to load as Visual Studio does. So I am using Rider. The other way to create a new script, of course, is to right-click, add, and you create your new behavior script and you give it a name. So now that we've talked about ways to create your new scripts, we are going to need some sort of way of controlling our script layout, because we're going to have a lot of scripts eventually. So we're going to call this, let's call this character controllers. I believe, yeah. I believe that's what I'm going to call it. Actually, no. So I'm going to create a new folder here. We're going to call it characters. And inside the character folder, I'm going to create a new folder and we'll call it controllers. Alright, now that I have that all set up, I'm going to come back into my writer here, and I am going to select the controllers. I'm going to say I'm going to add a new behavior script, and we are going to call this character movement. All right. So now that we have this character movement, if you notice, it automatically put this in what's called a default namespace. I'm going to change my default namespace to action adventure 2D. And we're going to also add, we're going to say characters dot controllers here. While I'm at this, I'm going to delete this blank script. So it's not there. So to recap, you're going to come into your scripts folder, create a folder called characters, create a folder called controllers, and create a script called character movement. Now, we are also going to want in here, we're going to add a new behavior script, and we're going to call this character movement view. So, actually, character movement animator control. So, and I misspelled movement. So, there's a reason that we have two separate different scripts here. So, you have the character movement animator control, right? Which we're going to use to send and pass on all of our controls, and it's going to control the animator. It's going to control this animator right here, right? And the reason we're doing this, and we're kind of separating out what we're doing, is we're going to separate the actual control logic from the control logic, the game control logic from the view stuff. So and the character movement animated controller here is going to depend on this here. Now the reason we're separating this out is so that we can have different animations based on our movement, but our animation scripts, we don't have to scroll through all our movement scripts and find the exact spot where we're doing different movements and doing different animations. We're just going to say, hey, if this character movement script here is in this state, you're going to play this animation. And you're going to get all your stuff that you need to play that animation from the movement script. So the movement script is going to handle all the logic of moving your character in the screen. So controls all logic for moving a character in the game world. Right? And here we're going to say this here just controls displaying the character in the game world. Alright, so for this, we're going to add a couple movement, couple variables that we're going to need. So we're going to do a required component, which says that anything that we put this script on is going to require a certain component. We're going to say we're going to require the type of, because we want the type of, and we're going to say we're going to require the character movement script. So now, if you add this character movement animator controller on, you will automatically have this character movement script. And we're going to fix this here. We're going to copy this using statement over. So on our character movement script, so our character movement script is going to control moving our character around on the screen. So we're going to do that using the physics. So we're going to say that our character movement script is going to require this physics body here, this rigid body 2D. So we're going to say, whoops, required component type of rigid body 2D. And oh, I may not have spelled rigid body right. We'll fix that here in a second. So we know that we're moving our character around using the physics system. So we're going to create a private serialized field. So a private field means that only this script has access to this field, right? We're adding this serialized attribute from it so we can see it in the Unity editor. I'll show you that here in a second. And we're going to make it a rigid body 2D. And we're going to call it rigid body 2D. Now you notice I got this little error here. If you highlight over it, it says that rigid body 2D is assigned, but its value is never used. The keyword new is required on rigid body 2D because it hides property component, Unity engine component, rigid body 2D. So for some reason, Unity at one point in time had these keywords, rigid body 2D, rigid body, things that you normally have on components, and it automatically fold these in and put it up. But over the years, as they incorporated new systems for Unity, they changed the way this is and decided that not every component will have these rigid bodies, and not every component. So to save some overhead encoding and on your components, they made it so that it no longer automatically filled out. But for whatever reason, they still have them associated, probably for backwards compatibility. So that's why we get this error about the requiring a new keyword. So we're going to fix that and say we want the new keyword, right? Add the new keyword. So private new rigid body 2D. Alright, so now we're going to use a Unity function called awake. And if you notice, we'll bring up the documentation for this. Give it a few seconds to open up for the scripting behavior to connect. Alrighty, so now that it finally loaded, we're going to add a mono behavior function here called awake. Awake is called when the script instance is being loaded. It's used to initialize any variables. And if you notice, it's got a little thing, a target equals game object prime with tag. So this does it anytime the script awakes or the component awakes or is the first time it runs. Uh, this is ran before start, so we are making sure that our rigid body is filled out before any other scripts can access this. That's why we're going to be using awake. So we're going to say rigid body 2D equals, we're going to say get component, and the component that we want to get is the rigid body, is a type of rigid body 2D, right? Bam. So now that will automatically fill out our rigid body 2D. So I made this a serialized field for now just to show you what it does with being serialized versus not serialized. So we will come back to our Unity script. And while we're here, let's do an awake function here. Awake. And we're going to say, we know that this is going to use the animator. So we're going to say serialized field. Private void, private animator controller, or animator, equals animator, and iMator. And we're going to say that we are going to require a animator on this as well. In fact, we're going to get rid of the private field or the serialized field here just so you can see the difference. Control animator, and we're going to add this as a required component too. And animator. Oops. Actually, we need to do type of animator. And we're going to get in the awake function. Underscore animator equals get component type of animator. Alright. So now that we have these, we are going to come back to our Unity, and for the fun of it, I am going to remove our rigid body, right? And remember that we have our animator control view here and our character movement script here, right? And if you look at our animator control, we're requiring the type of movement and the type of animator. And if you look at your movement script here, we're requiring the type of rigid body. So we have our player effect script here, right? And we're going to open this prefab. So we're messing with the prefab. Overrides, revert all. So now we're editing the prefab. So on our editing of prefab, I want to remove this component just for fun, just to show you what happens. And we're going to add our component, right? You can either click add component here, or you can do is you click on the script and you drag it here. Now we are going to add the character movement animator controller. And if you notice, when we added that, it added the character movement script and a rigid body 2D. But wait a minute. Why did it do that? Why did it automatically add these two components for us? Well, that is because when we added our animator controller here, we said, hey, you need to have a character movement and an animator. So we added the character movement animator controller, right? I said, okay, animator, yep, this component has an animator on it. Check. Okay, character movement script. Oh, nope, it doesn't have it. So it automatically added this character movement script for us. This character movement script said, hey, you need a rigid body 2D attached to this component. So the character movement script said, okay, I need a rigid body 2D. Let me add my rigid body 2D. So it automatically added a rigid body 2D to our character. So now that we have everything that we need to script, and if you notice, if you see this rigid body 2D right here, shows up, and if you look at our character movement animator controller, we have nothing. So come back to our scripts. So character movement animator controller, if you notice, we made this a private animator. Now watch what happens when we say public right here. So we made this public. Come back to Unity. When it recompiles, you notice it popped up and said, hey, where's your animator? Right? And we can drag, fill it out. Right? It fills that out. We're going to select none. But hey, wait a minute. So why are we using a private serialized field here? So the reason we're using a private serialized field here is because when you make this public, you can access this animator from outside of this class. I will have some other examples later on where we're going to be accessing. In fact, when we get down to filling all this out, we will be accessing fields from inside here, inside this class. But we don't want this class to be able to control these fields. So that's why we make our rigid body, our components private, right? Private means that only this class can access it and only this class can use this field. But we want to be able to assign it in the inspector and make changes in the inspector. So we add this here serialized field, which tells Unity, hey, I know that it's only going to be used in this class, but I want to have a nice little GUI here to make settings, and it'll automatically add it to the settings. So, but we do not need this, and because I'm going to rename this to M underscore rigid body to go with my naming conventions, because it's a private field, right? And we're going to do the same thing here. Because it's a private field, we're going to rename it to animator. Alright, so now we save these classes and you come back out, they're not here. Right? But, well, that is for some reason. Oh, it's because it's still a public. That's alright. Now if you click play, watch what happens. Oh, I got maximize on play. Game. Maximize on play. I don't want to maximize on play. If I click play, watch what happens. It should automatically fill out. So if we click play, you notice that it automatically filled out our animator right here with the player animator. It wasn't showing up earlier because what I had highlighted here, if you notice, I was in the prefab. I'm editing the prefab. So when editing the prefab, it doesn't show up here. That's because you got to be under the scene view for it to show up. So notice that it automatically filled in the animator controller. And I'm going to tell you that it automatically filled in the rigid body 2D. You just can't see it. So now let's come back to here and say that I want this to be a private field, because I don't want anything else to access it. And the only time that it's getting set is in the awake function. Alright, now that we got that, let's think about how we're going to control our character. So, let's start with playing with our, we're going to add a couple fields here. Private update and private fixed update. And add a fixed update field here. Alright, so updates how many ever frames a second, but as many times as it can. Fixed update is where we're going to use for all our physics, and we're going to use our physics to control our update, or to control where our character is displayed on the screen, where he moves to. So let's play around with this first. So we need a vector 2, right? Rigid, we're going to say position. And we're going to set this position equal to the rigid body dot position. All right, now let's move this position. We're gonna move them to the left. So position dot x equals we're gonna say plus equals 1. Let's see what happens. All right, and now we're gonna say our rigid body dot position equals position dot equals position. All right, let's see what happens here. Oh wow, did you see that? See, he just shot across the screen. That's not 100% quite what we wanted. So let's add in here. Let's add something to control our speed. So private float speed. We're gonna say movement speed. Movement speed. And while we're here, we're also going to say private float. We're going to say run speed. Let's set our movement speed to be 2 or 1. We'll say 1F. Let's set our run speed to be 2F. Alright, so now we're going to need a boolean. And let's make these serialized fields so we can access them and set them from the Unity editor. Serialized field, serialized field. Alright. So now that we have that, we're going to say the speed at which a character moves on the screen, moves in the game world. Alright, perfect. And we're going to say this is the speed at which the character moves while running in the game world. And let's add another attribute here. We're going to say tooltip. And we're going to copy our tooltip. And we're going to do the same thing. Let's do the same thing for our run speed. While running. Alright. Remove unnecessary white space. Because I don't like all that extra white space. Alright. So, let's do this multiplied by speed. Let's just multiply it by movement speed for now. And now let's see what happens when we hit play. It takes off, moves a little bit slower, right? Movement speed of 1. And while we're at this, we're going to say times time dot delta time. So this keeps it frame independent, so it doesn't matter whether we're running at 5 frames a second or 60 frames a second, whatever we're running at, it will move across the same speed. There's a lot more explanations and details if you go through a lot of the other characters. Let's just say that it's for the movement speed. So let's see if I. All right, I hope that this time dot delta time doesn't confuse you too much. So now instead of changing the position, we're gonna say the rigid body dot velocity equals this, and now see what happens when we click play. And nothing. Why is nothing happening? Give me a second. Let me see if I can figure out why nothing is happening. Okay, so I figured it out. Why he wasn't moving. So he's not moving because our movement position is 0, 0, 0. It wasn't adding anything to it. So what I'm going to do here is instead of this, we're going to say our equals vector 2 dot 0, because we don't want him to move at all, right? So we're going to say m movement. Let's say movement direction equals vector 2 dot 0, and then we're going to come in here and we're going to say okay, so we're going to add 1 to our movement direction, right? And then we're going to say our velocity equals movement direction times movement speed times time dot delta time. And we're going to save this. So if you notice what happens, watch what happens when we play this. Here, let me put my cursor right here at the player's feet. If you notice, he's moving very, 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 very slowly. So now, if we increase this to 10, he moves a little bit faster. 100, he moves really quite a bit. So now we can control how fast our player moves, right? Alright, so in fact, let's make sure that we do this a little bit better here. We're going to change our movement speed to be defaulted to 10, and our run speed, let's default our run speed to 100. Alright, so we're going to say 10, 100. And actually, we need to make sure that we apply this, revert all, come back to open our prefab, movement speed, we're going to say 10, 100. Alright, cool. Now we're going to come back here, overrides, 10, 100. Reset. Revert all. Why is that not? Delete. Drag my prefab back up here. Huh. Delete. Player like Zelda. Movement speed is 10. Run speed is 100. 10. 100. Okay. Now let's move our player Zelda back in here. There we go. I don't know why it wasn't taking it. But now notice that our player moves all by itself to the right. So let's come in here and copy this and make a factor to update direction. What do I want to call this? Alright, so let's come in here and create a field called update movement. So private void update movement. Right? And in this update movement, we're going to paste the code that we just did. We're going to get rid of our update field here because we're using fixed update. We're going to say update movement. Now all our movement direction is set through here. Okay, now that we have this, let's get rid of this vector 2 from here, right? And let's say that we want a movement direction here. The direction the character is moving. And we will rename this to M movement direction. And we're going to say here that we're going to delete this. Alright. And now if you notice that we have a movement speed and a run speed, right? So let's come in here and say float speed equals movement speed. And let's add a boolean here. We're going to say, do we want to make this public? Yeah, we'll make this public. We'll make a public boolean. Here, we'll say, is running. Now we're going to do, we're just going to say is running. Bam. And we're going to come in here and say, if our character is running, we're going to say our speed equals our run speed, right? Oh, we got to say if is running. Actually, we'll do this even better. We're going to say speed equals, watch this, if, we're going to say speed equals is running, question mark. So if is running is true, our speed is going to be our run speed. If it is not true, our speed is going to be our movement speed. And then down here, we're going to say movement direction times movement speed times time dot delta time. Alright, so let's add a function in our update here. Private void update. And we're going to say m oh, we got to get rid of this vector2 here. This won't work. So we're going to say our m movement direction equals, we're going to just say vector 3.1. Right? Let's see what happens. And yes, I know this is a vector 2. So we'll say vector 2.1. So let's see what happens here. Alright, so if we are moving, it should be moving. Hold on. Why does this not work? Okay, so I figured it out. Let's comment out this line right here for now. I was resetting it back to 0, so it wasn't moving at all. So now if we do this, notice that he's moving up to the right. Okay, so now we got some sort of movement going on. But let's add a little bit of freezing into our thing. Private boo is frozen. So here in our update movement field, we will see we're going to do something similar to this. We're going to say if is frozen movement direction equals vector 2, 0. Alright, so now let's play this and see what happens. Now remember I made these public. This is why we make these public. Running, not running. And why is frozen's not showing up? Oh, public. So now if we play, well, look, he's frozen, he doesn't move. We're telling him to run, he's not running. Running. Alright, so now that we have that all incorporated, let's add another function here. We're going to make this public. Public. Set public void, because we're not going to return anything. Set movement direction. We're going to say vector 2 desired direction. Alright. And I misspelled something. Yeah, I left off the E. And off the R. Direction. Alright. So now we're going to say our movement. We're going to say if is frozen. Let's see here. We're going to say movement direction equals desired direction. And we're going to add a new thing here. It's going to be a mono behavior. Behavior C# script. And we're going to call this base character controller. And we're going to add another one here. And we're going to call this input manager character controller. Alright. Man, I misspelled controller again. I hate it when I do that. So, we're going to say this inherits from base character controller. So the reason that we're going to do this is we're going to say that this is going to control all of our character movement, right? And we're going to have one that says we're going to use our input manager to control our character. And we're also going to have, later on, we're going to have some sort of AI behaviors to control our enemies and such, so that all we can do is we'll inherit straight from this base character controller to make those, and we can easily update how our character gets controlled by the base controllers. Alright, so let's come back over here to base controller, and we're going to say we're going to make this a public abstract class. And we're going to say that we are going to require a component of type character movement. Alright, so now we're going to say here, we're going to say private, if I can spell, I can't spell private. There we go, private character movement controller, character movement, and we're going to call this M character movement. Alright, and we're going to say in our, actually we're going to say protected character movement, because we want this character to be utilized in our base controllers. So we're going to say in our awake function, we're going to say our character movement script equals get component type of character movement. Alright. Now we're going to say we're going to have an update here. And in our update, we're going to say update movement. And we're going to create a protected abstract void update movement. Alright, so what we did here was we used our update method to update the movement of the character. So we created a abstract class, right? Which means we can't inherit from this. But with this update movement here, we made it saying that anything that uses the space character controller has to have this method. We're not implementing this method, but it has to have this method. So in our base character controller here, we get errors because we are not implementing the update movement. Our update movement method here, we're going to say alright, so we're going to say, in fact, we're going to go one step further. We're going to go one step further. We're going to say here, we're going to make this private. I know, I can't make up my mind whether I want this private or public, right? And we're going to say, m character movement dot. Actually, we're going to have to expose this. So, I'm sorry, guys. Bear with me. So, over here, we're going to say, in our update movement, we're going to say float v equals get input, because we're going to use the input manager, right? Dot get raw access, or access raw. And what access do we want to get? So we're going to come over here in our project settings and look at our input. This is all the inputs that are already listed, right? So we want to use vertical movement. So we're going to say vertical. And then we're going to say float h equals input dot get access, and we're going to say our horizontal axis here. Okay. Now we're going to come in here to our character movement, and tell it to move. Set movement direction, and we're going to say new vector 2, and we're going to pass in our vertical and our horizontal. Actually, I'm sorry, our horizontal and our vertical movement for our Y, because vertical is up and down, horizontal is left and right, right? Now we'll save this. So now come over here to our player, and we'll make sure we're in the prefab, because this is a player. We're gonna add a component. Now watch what happens with these different component scripts that we just made, right? So we have this base character controller. Let's try adding that. You get an error. Can't add script behavior base character controller. The script class can't be abstract. Alright. So now that we know that we can't add just base, that makes it so we have to know we have to add some sort of stuff for us, right? Now we added this here input manager controller. Now click play. Now watch what happens. Oh, oh. We did something wrong. What did we do wrong? Character movement. Oh, so come back to your character movement script here, and we're just gonna delete this update field. Now that we have this update field deleted, so we're not doing any updating, right? All we're doing is our own character, and because this here is we're gonna put this up here with our movement direction. Okay, so now if we click play, watch what happens. Our character isn't moving, right? Now if we press left or right, our character moves on screen. Alright, so now we have that all updated. Now let's add in just a tad bit more polish here real quick, because this is real easy. So if you look at your inputs, we have fire 1, fire 2, fire 3, jump, mouse X, mouse Y, and to repeat it again, right? So we're not using jump right now. And right now jump button is placed to space. So let's change jump to run. Alright, and we will also do the same thing down here for this jump. We'll change this jump to run. Now if you notice, our positive button here is space. And if you look down here, our positive button here is joystick button 3. So what this is doing is allowing you to use a controller to input and change out, to do the same inputs. So whatever's in your input manager here is how our inputs are controlling. Unity also has a new input version that's a little bit more difficult to set up, I think. So we're just going to go with the input manager for now. And that is why we created this class here. We created this base character controller class. Oh, whoops. We created this base character controller class so that we can easily update our different types of controllers. And this one we're saying we're using our input movement manager. Maybe later on we want to say, instead of using input movement manager, we want to use the new character movement, or the new here, player. I think it's under player. I'm not quite 100% sure where it's at now. But Unity has a new, right here, active input handling. You have input manager, input system, or both. So Unity has this new input system that you can set up your different inputs similar to the same way as an input manager, just it's more of the new way of setting up inputs. I think it's got a lot of potential. I just think they have some bugs to work out. But using the input manager, we have these axes that we can use, or these buttons. And when we come in here and say, oh look, I am using a controller, or I can use my keyboard, right? Really simple, really easy. And we made it really simple and really easy to change out how we use our input based on which controller that we assign. We can also create an enemy AI controller here that automatically moves a character around, and all we have to do is pass that input, the inputs that we want to do. So real quick, let us add a movement here. So we're going to say, we're going to add a new serialized field called toggle. We're going to say private boo toggle character run. And we're going to set this to true. So what we're going to say here is if our character run button is toggled, that means we press the button once and the character is running. If this is set to false, then we're going to set our character. So if input, if toggle character run is true, we're going to say and actually no, we're not. Not going to combine these. We're going to say if character run is true, and we're going to say if input dot get button down. So if we press the button down, what button we want to use? Well, let's see here. Come to our things, and we're gonna come to our input. We've got fire 1, fire 2, fire 3, left alt. Yeah, left alt. So what's fire 1? Fire 1's left control. And what is fire 3? And what is fire 3? Fire 3 is left shift. So we'll use fire 3. Let's rename fire 3 to run. And come down here to fire 3, run. So now, if we come in here and say run, so if we press the run button, we're going to say character movement dot is running equals the opposite of character movement dot is running. Alright, so now outside here we're going to say else. So meaning that character run is false, we're going to say if, or actually we're going to say else if, nope, we're going to say, else character movement dot is running equals, and we're going to say this equals input dot get key get button run. All right, so don't forget our columns. So now let's come in here and test this out. So right now our character is set to toggle run. So let's see. Let's what happens if I press the left shift button. Alright, so if I press the left shift button, if you notice I press the left shift button, our run is toggling. It doesn't matter if I'm holding it down or not. So now let's make it so it's not toggled. Now, when I press the left shift, he runs. When I let go, he goes to walking. And that's what we want. Alright, and that concludes this portion of the video. I think we will come back to watching, moving on to adding our animation and face interactions. See you guys next time.